Hello, ladies and gentlemen. I hope you are fine wherever you are. I am the Acca tutor, Mr. Jerry Kulu, and in this video, I'm going to take you through the process of capital rationing or capital budgeting. This is the area which we need to tackle as we pursue our investment appraisal topic. Okay, capital rationing or budgeting. If you still remember, in the previous videos, we tackled issues to do, a various lot of issues, okay? We tackled them, and so far, you are now comfortable with how to compute a net present value of a project. That's something that you guys are now capable of doing, okay? But we now then have to go a step further in trying to make sense with regard to the issue of capital, all right, because capital is not an easily found or easily obtained resource. It is scarce, all right, and in many situations managers are confronted with uh, decisions as to how to proceed given the smallest amount of capital available. So the purpose of capital rationing is to inform managers on the best ways to maneuver the investment trajectory when they are confronted with a series of projects but with limited capital available in their coffers. So there are two ways, there are two forms of capital rationing or capital budgeting. The first one is hard capital rationing. Okay, hard capital rationing. All right, hard capital rationing is a situation where, because of external development, the company cannot get funds to finance whatever project they want to do, okay, or to finance all the projects that they can invest in. All right, so the company has got projects which need to be done, but because of external forces beyond their control, they can't get those funds. For example, the borrowers or the lenders of money, the external financiers, are not willing to give them money. So in that situation, the rationing exercise that will be taking place is capital hard capital rationing. Then we have got a situation where we have got what is called soft capital rationing. This is as a result of common specific situations or common internal developments. For example, managers have just decided not to finance beyond a certain budget threshold. So in that case, we call that one an internal capital rationing exercise or a soft capital rationing exercise. All right, so that's soft capital rationing. Now, what then do we have to do? Whether it is hard or it is soft capital rationing, we then have to have a criteria on how to to proceed going forward. All right, there are projects which we need to do. So how do we maneuver? How do we come up with an informed choice? All right. So the choice depends on the characteristics of each project, okay, of all the projects. Are these projects finitely divisible or finitely indivisible? So we need to ask ourselves, is the project finitely divisible or infinite? Sorry. Okay, or finite indivisible? These are the very important questions, ladies and gentlemen, because by the end of the day, whatever rationing that is there, all right, we need then to pursue what is called shareholder wealth maximization, wealth maximization, shareholder wealth maximization. And this one is done by the principle of NPV, the net present value principle. All right, that's the principle that is in line with shareholder wealth maximization. Now, if the project is finitely divisible, it means that we can invest in whatever fraction of that project up to the 100% threshold. Okay, so we can invest, let's say we are confronted with 3 projects, project A, project B, and project C. We can invest 10% in project A, 20% in project B, and then maybe 70% in project C. Okay, or 30% in project C, doesn't matter. All right, now, but how do we determine, how do we arrive at whether we should invest in 10% of project A, 20% in project B, and so forth? The idea, if the projects are finitely divisible, we first have to determine their profitability index. Okay, profitability index, this is given by each project's NPV divided by the initial investment. The project's NPV divided by its initial investment. So this gives us the idea of the NPV per dollar invested. Okay, how much do we? So we need to rank these projects in terms of their dollar. Their NPV per dollar invested. So the NPV per dollar invested is given as NPV over initial investment. Then that project that has got the highest NPV per dollar invested is going to be given priority, followed by the other project that has got a better NPV per dollar invested until we exhaust all the funds available. So that's the technique which is used if we are having finitely divisible projects. What about if we have finitely indivisible projects? These projects are finitely indivisible. What then are we going to do? Because you can't invest in 10% of any of those projects. Once you pick the project, you need to do it up until you finish. Okay, you can't do part of the project. It doesn't work like that in a finitely indivisible project situation. So in this case, you need to then determine a combination of those projects which will going to give you the maximum combined NPV. All right. So that's the idea here of all this capital rationing issue. So let us let us go through this example and see what we can get out of it. Okay, ladies and gentlemen, this is the question. All right, a company is the following 4 projects are available. All right, year 0, 1, 2, 3, 4. All right. And okay, there is one thing I want to point out. When you do your if the projects are finitely divisible, I say that you can invest in whatever fraction you can invest in. All right, provided you have done the initial computation of the NPV per dollar of the investment invested. Okay, so when you do your ranking, that's when you can say, I want to invest 10% in B, 20% in C, or 70% in B. All right. But one thing you have to also understand is that there is an assumption you need to make. All right. So if you invest in 10%, if you invest 10% of a project, or in 10% of a project, then the assumption is the NPV you are going to get from that investment is equal to 10%. So that's the assumption. All right. So if you invest just 10% in a project, you're going to get the NPV, which is equivalent to 10% of that project's NPV. That's the idea. All right. So with that in mind, we can safely now attempt this example. So you can see that these were the initial investments of each of these projects. Okay, project A 500, project B 600, project C 300, and project D 400. Okay, and then these were the cash inflows. As you can see, they're positive there, and then the NPVs of these projects, all right, were as given. All right, these are the NPVs of each of these projects, and you can see, all right, the project A was having an NPV of 50, project B 57, project C 36, and project D was having an NPV of 50. All right. Now, the question is saying, what should the company's investment decision be? What should the company's investment decision be? All right. A, when there is no capital rationing. Okay. There is no capital rationing. All right, which means we can do all of the projects at once. All right. Funds are available. All right, we can do all of the projects. So in this case, we are only going to be guided by the NPV criteria. Okay, and the NPV criterion says that a project that has got a positive NPV should be accepted. So we are going to do all the projects because they are all having positive NPVs. As you can see there, the NPVs are positive. So when there is no capital rationing, it means that the funds are readily available to do everything what we want or we can do. Everything that is justifiable can be done because the funds are readily available. Okay. Now, part B is saying when the capital is restricted to 1,600 times 0 and the projects are infinitely divisible. Now, in this case, the projects are infinitely divisible, which means that we can now do the profitability index computation to determine which project should be done first, which one should follow, and so forth. So let us determine that. Okay, here we know that we've got project A, project B, project C, project D. All right, and our NPVs as given. Project A has got 50, project B 57, 36, 50. So 50, 57, 36, 50. So those were the NPVs and the initial investments of each project. So we need to divide because we want to determine the NPV divided by initial investment so that we come with the NPV per dollar invested. Okay, NPV per dollar. So the initial investment of these projects were 500, 600, 500, 600, and 300, 400. Okay, so you can see that the NPV per dollar, NPV per dollar invested, here we are going to have 5, 10, so that's 0.5 All right, and then here let me use my calculator. That's 57 over 600. Okay, that's 0.095. Then 36 over 300, 0.12. And lastly, 50 over 400, that's 0.125. So let's do the ranking now. Ranking. Okay. Remember I said this is the profitability index. Okay. The NPV over initial investment gives you the profitability index. Okay. And then, so if you rank, if you rank this, you can see that the highest NPV per dollar is found on project D. So we're going to do project D first, followed by project C, followed by project A. And then lastly, if we still have the money, we then attack project B. So how much are we going to spend per project? Okay, we can then come here and say this is how much we are going to spend per each project. Okay, because we are given these projects, there are 4 projects. Okay, they are 4 projects, and we only have got 1,600 available. All right, according to the question, that's 1,600 is only available in year 0. So what we are going to do, we have got limited funds. So we're going to invest in 100% of investment. That's 100% of D. We are going to start with project D, and project D requires how much? Project D requires $400. So that's 400 is going to be spent. All right. Okay. Let me try to fit everything here. All right. 400. This is the amount, and this is the NPV. Okay. The NPV of D was 50. So 50. Then we are going to do 100% of the following. That is C. C, that's number 2. And C requires 300. Here, you can just use this information since we took that one for D and this one is for C. That's 300, and its NPV is 36. Okay, 36. Then we still have got more money left because we want to utilize 1,600, so we can do 100% of A, because A is number 3 there. A requires 500, and its NPV is 50. Okay, and the NPV of A is 50. All right, then how much are we left with? 400 plus 300 plus 700 plus 500, that's 1,200. So we are left with only 400. So that's 400. Okay, 400. We can use that one to finance project B. Okay, 400 can be used to finance project B. But how much NPV are we going to get? Because if we invest 400, obviously we are not going to get the 57 or original NPV of B. Okay, we're not going to get this much. This is the original NPV of B, but that NPV was only obtained when we invested in when we invested $600, but now we are only going to invest $400. So do not expect to get an NPV of $57. Things have changed now. All right. So you need then to proportionate. Okay. So what you do is you say 400. All right. That's 400 over the original investment 600 multiplied by the original NPV 57. That's the original NPV of B. So obviously we are going to have, this is going to give us, let me use my calculator here, that is going to give us 38, NPV of 38. Okay, so in terms of percentage, you still going to say 400 over 600 multiplied by 100%, and you can get, you are only going to invest about 66.66% of B. All right. So this will exhaust all our money, 1,600, which is the amount of money available, and this is going to give us a total NPV of 50 plus 36 plus 50 plus 38. That's 174. That's the total NPV we are going to get if these projects are finitely divisible. I'm sure, ladies and gentlemen, you are benefiting and you're understanding how these things are being worked out. Now, let us then attempt the last situation where the projects are not infinitely divisible, okay, or are finitely indivisible. All right, so the same capital restriction is still 1,600, ladies and gentlemen. So let's move on. All right, let's move on and see what we can do. All right, like I said, if the projects are finitely indivisible, we then have to do those. I mean, that combination of projects that is going to give us maximum maximum NPV in combination. All right, the maximum NPV in combination. So this one now is an issue of just picking up things. All right. So we can utilize this space. Let me try to rub off one or two things. It's an issue of because you can do part of the project, you then have to do everything. All right. So we've done everything and determined the NPV of each project at the cost of capital. The 10% here is the cost of capital. All right. Cost of capital 10%. All right. So everything has been done. So what happens is we can't do a fraction of each project because they are indivisible. All right, the projects are indivisible. So what we do is we then have to determine a combination that is going to give us maximum NPV. So it's a trial and error issue. Okay, it's not going to be an easy task if there are a lot of projects. Okay, process is going to be iterative. It's going to consume a lot of time, but at the end of the day, that is the way to go because we need to maximize shareholder wealth. So let's try a combination of because we can't do them all because we are restricted by 1,600 cash available. So if you add up these initial investments, 500 plus 600, that's 1,100 plus 300, that's 1,400 plus 400, it becomes 1,800. Then it means that you can't do all of them. So the combination of A, B, C, D is ruled out. So we need to at least pick three. Okay, let us pick three. Let us say combination of A, B, C. A, B, C is going to give us NPV of 50 plus 57 plus 36. All right, and so the NPV there is going to be 50 plus 57 plus 36, that's 143. Excuse me. All right, and then a combination of A, C, D. A, C, D. This one is going to give us 50 plus 36 plus 50. So 130, 50 plus 36 plus 50. That's 136. Okay. 50 plus 36 plus 50. Yes, 136. Okay. What of A, B, D? A, B, D. 50 plus 57 plus 50, that's 157. Okay, 157. What of B, C, D? B, C, D. Now, let me see. A, C, D. Now, there is a problem with A, C, D. Okay, because of our capital restriction. Okay, that's 500 plus 300. That's 800. Okay, it's okay. Seems we are still in the same. Yes, that's 800. That's 1.2. Okay, it's fine. What about ABD? That's 1.1, 1.5. Yes, that's okay again. BCD, BCD. Yes, we are still there in terms of capital restriction. That's fine. Now, in terms of our NPV, we're going to say 57 plus 36 plus 57 plus 36 plus 50, that's 143. Let me cross check again. 57 plus 36 plus 50. Yes, that's 143. Now, we've done that. Then let us pick which project has got the highest NPV. All right. You can see from the combinations given that project ABD, projects ABD, the combination of the project ABD is going to give us a higher NPV. Therefore, that combination maximizes shareholder wealth and should be pursued. So it means that it is worthwhile for the company to invest in projects ABD because that's the combination that is going to yield the greatest value to the shareholders. Okay, now let's talk of something here. We've done that. There is a time when we need to know when we should replace a particular asset. All right, so that is the video that is going to come in this next segment. Okay, the issue of determining the optimum asset replacement policy, okay, the optimum asset replacement policy. Please stay tuned to the next video. Thank you.